Well, good morning, everybody. If any of you have been joining us this past week for the corn crop hour, you might notice that I am not Connie Strunk. So I am Philip Rosebohm. I am the IPM coordinator based out of Brookings, South Dakota. Um, and I'm basically filling in for her. She wasn't able to make it today. So hopefully, this is the first cropper I've run this year, so hopefully it goes pretty smoothly. Our speaker for today is Jason Clark. He is the assistant professor and the extension soil fertility specialist based out of Brookings, South Dakota. He does a lot of soil work. Um, just like Connie, though, Jason wasn't able to be on live today. But Jason's really good about making recordings. So we do have a recording of his talk that he was going to give today. So it's nothing old. It's pertinent, brand new information. But instead of a live recording of Jason or Jason actually being here, it is a recording. So just keep that in mind. You can ask questions. Kira has posted a basically explanation how to do questions using that Q&A function, as well as the CCA credits. You will still get those credits based off of the recording from Jason. But with that, I'm going to start that recording. Just let me know, Kira, Sarah, support crew, if it's not going well, just put it in the chat and let me know. So with that, thank all of you for joining us, and hopefully you learned something new today.
Hi, my name is Jason Clark, and I'm here at South Dakota State University, and today we're going to go over how we're working on improving our corn nitrogen rate recommendations. So let's go ahead and look at some data and see how we can improve them. All right, so first of all, we want to spend a little time on what exactly are our nitrogen rates looking like in South Dakota. So here in this graph, we're going to see really quickly across 45 different site years what our nitrogen requirements have looked like over the last several years. So we can see here we have quite the range. We have some sites going from 0 all the way up to 200 pounds of nitrogen per acre. So this is quite a variation. The mean of all this is around 96 pounds of N. Right here in the middle is where we're normally hitting for nitrogen requirements in South Dakota. So how do we best predict these nitrogen rates since they're so varying across the state? This is this next part. So traditionally to this point, we've been using what we call a yield goal approach, using a multiplier of 1.2 for the amount of nitrogen needed to produce 1 bushel of corn. So the equation looks a little bit like this. So we have our equation where we have our yield goal, and we're going to say 144 bushels of corn for this example. We're going to multiply that by our coefficient, or a multiplier of 1.2 pounds of N per bushel of corn. We're then going to go and subtract our soil tested nitrogen from our 0 to 24-inch sample. Then we're going to subtract any legume credit we might have if our previous crop was soybean or alfalfa or things of that nature. And if we're recently in no-till within about 5 years of no-till in that field, often we need to add an extra 30 pounds of N in that field. So this is our field's example. Our nitrogen rate requirements are about 105 pounds of nitrogen per acre. So if you divide that by 46%, which is how much nitrogen is in our urea, we're going to get about 220 pounds of urea per acre that we need to apply to this field. So the next question is, how accurate are we? So let's find out. So to find out how accurate we are, we looked at different research sites, different locations on farmers' fields throughout South Dakota. The highlighted states you can see here in dark blue are those sites where we have done nitrogen trials in those counties. We've done 45 of them since 2018. 32 of those sites were conventional till, 13 were no-till. 35 had soybean as a previous crop, so mostly soybean, corn in this area. And then we had 10 sites where we had a wheat, a corn, or another crop preceding our corn crop. So next we're going to learn what the difference was between our recommendation and our actual nitrogen requirement needs. So that's what's on this next graph here. On our y-axis, as you can see right here, we have our pounds of nitrogen per acre. And then we're looking here where we have our sites in our central region, and also these ones over here in our eastern region of the state. So this red line represents our nitrogen recommendation from SDSU, and then this next line is going to be our actual nitrogen need. What we want is we want these two lines to line up as close as possible. That means we're being very accurate. So we can see here, this blue line shows up. We can see some sites are doing quite well, while others, such as this one right here, there's quite a bit difference between the recommendation and what was needed. But other sites we can see, such as right here, are those sites that did very well as far as our recommendation and what's needed. So we look at just the difference between this red line and blue line to help us see how well we're doing. That's in this next graph here. So we took that nitrogen recommendation, that red line, and subtracted it from our needed nitrogen, that blue line. So if we're at 0, we're right on. It's exactly where we want to be. If we're above the line up in this area, that means we are overestimating how much nitrogen we need. And if we're below it, that means we're underestimating the amount of nitrogen we need for our corn crop. So here, currently, you can see the closer to 0 are, the better we are. So overall, we're about plus or minus 67 pounds of nitrogen per acre. So I think there's room for some improvement. So how can we improve? And that's this next question we're going to go over next. So if we look at this equation that we've already spent some time on, one of the things that's changed over the years is this coefficient or multiplier 1.2. And where that multiplier comes from is taking our soil test nitrogen from 0 to 24 inches, adding it to what nitrogen we needed from fertilizer. Let's say that's 240 pounds of nitrogen per acre. And then we divide that by their bushels per acre. If we do that in this instant, we get about 1.2 pounds of N per bushel of corn. So that's what we've been previously, and that's why we use that as a multiplier. But how accurate is that number today? Well, let's look out of this data we have from these 45 locations. We can see here that our y-axis is now our nitrogen coefficient, or that multiplier, and we still have our regions and our areas down here on the x-axis. So traditionally, that average has been here about 1.2, but we're actually seeing across this data we have here, that average is actually much lower, around 0.9 to 1, depending on what region we're in. Now, if we want to look at the recommendations based on region and based on this new number, that's what we're going to look at now. So we're going to look at this graph, which is similar to the last one. We're going to look at the difference between the recommendation of using 1.2, 1.0, and 0.8, and subtracting that from the nitrogen needed in that cornfield. So first, we're going to look at that 1.2 that we've seen already. Now, what we want to see is when we do this 1.0 in blue, does that blue line get closer than the red line to that 0 mark, that 0 line right here? So if we do that, we see in these sites up here that are overestimating nitrogen needs, we get closer. Those sites that are below the line that are underestimating using 1.2, we're getting farther away from 0, which isn't what we want. So if we do 0.8, we see that some of these sites above are getting closer. Some are actually, such as these ones over here, are starting to get below the line, which is not what we want to see. And those ones that are already underestimating are getting even further. So we then kind of mix this into 3 different groups, and the 3 different groups, as we'll see on this page right here, we'll see our underestimation, those top 25%, those ones were overestimating the top 25% of those ones, and then the middle 50% of the data to see how we're doing overall. So first of all, we'll look at those ones where we tend to underestimate. So if we change that coefficient, that multiplier from 1.2 to 1 to 0.8, you can see that we start going further away from 0. So when we're underestimating, which we tend to do this in drought-conditioned years, a lot of these sites in here were under drought conditions, we get further because it's less efficient of a system. However, when we tend to overestimate, such as these ones here, and we change from a coefficient of 1.2 to 1 to 0.8, we're starting to get closer to that line, that 0 line. And if we look at the middle 50% of our data right here, we can see as we go from 1.2 to 1 to 0.8, we're getting closer to around that line. Actually, when we get to 0.8, we seem to be a little bit below that line, more average than the 1.0. So we take all this data here together, and we look at it together. That's what we're going to see in this graph. We're going to see as we go from 1.2 to 1 to 0.8, we start to go down. We get around this line, around 1.0, and we start to get more below it with 0.8. So on average, for 1.2, we're about plus 48 pounds per acre. We are on the blue line, or the 1.0 multiplier, we're plus 13. And then when we get to 0.8, we get about minus 22. So we can see we're overestimating less, but still pretty close to 0, and now we're starting to underestimate more than we overestimate with the 1.0. So, and we're also, most of the data is right closer to 0 in this data than so with right here. So a lot of what this shows us is that that 1.0 might be the most accurate that we can get in our current recommendation system, and actually be better than our 1.2. And this isn't something that's changed. That 1.2 hasn't always been 1.2. If we look back in time, we see in 1975 it started at 1.45, decrease, decrease. Now in 2022, I'd say based on our data, that 0.9 or 1 mark is about right where we want to be. In fact, the recommendations going forward is that this 1.2 are going to be 1.0. So we're going to take that yield goal, multiply it by 1, subtract our soil test nitrogen, subtract any legume credit, and that add any no-till debit to it. So the question is we have all these different factors. We have our yield goal factor, our coefficient, our multiplier, our soil test N, our legume credit, our no-till debit. All of these different things are in this. So how much do each of these help us improve our overall equation? That's this next part we're going to look into here. And that's what this question becomes here. So here we're going to look at improvement. And right now on our y-axis, we're going to look at the percentage of the time having that factor in there helps us improve our equation. So the first thing we're going to look at is recently we've moved from a 1.2 multiplier coefficient to 1.0. And we're going to look at whether this is across all of South Dakota, the eastern region, and the central region. So if we look here at just moving that 1.2 to 1.0, 73 to 81% of the time we're seeing an improvement by doing so. Now if we add soil test nitrogen, very similar, in the central part of the state it's the lowest at 60% improvement, but then the rest of the state, 76 to 81% overall, we're seeing improvement by using soil test N in that equation and not forgetting to use it. Now if we use that legume credit, if we grew soybean or alfalfa or something else before, so incorporating, making sure we use that legume credit where needed, we see again 70 to 76% of the time we're seeing an improvement in our recommendations by using that factor. Now using our no-till debit, that plus 30 pounds, is similar. In central region, only 40%, but eastern and all of South Dakota, 68 to 77% of the time, we're improving it. So generally, we're seeing that when we're using these different factors, they're each improving our nitrogen rate recommendation, but by how much? So that's what we're going to look at now. Instead of percentage, we're looking at actually pounds of nitrogen per acre. So we look at using that 1.0 instead of 1.2, we're seeing across South Dakota, we improve our nitrogen recommendation by 19 pounds of N per acre, 7 in the central, 23 in the eastern. Now, if we look at our soil test N, we're seeing 10 pounds of N per acre improvement, 25 to 29 for all the state or the eastern part. And if we're improving it by 25 pounds of N, that means we're saving 25 pounds of nitrogen, which is $1 a pound nitrogen. That's $25, $29 per acre, which can add up over several acres in a field. Now, if we're looking at that legume credit, if we're adding that into the equation, we're saving anywhere from 3 in the central to 13 to 17 pounds overall across the state of our recommendation, improving that accuracy. Now, our no-till is a little different story. We're seeing on average, we're actually lowering. But that shows us this is looking at no-till regardless of the number of years we've been in no-till. But we've seen that after 5 or 6 years, that tends to go away. So that's likely an update that needs to come into the recommendation in the coming years as we get some more data in on some long-term studies that we're currently working on. Dakota. And a lot of the reasons you can see here on this graphic, we're seeing an increase in corn yields. We are seeing an increase in fertilizer rates as well. Our climate in South Dakota is changing quite a bit. Our management is changing. We've gone a lot from tilled practices to no-till. Our rainfall is a little bit more sporadic. But the biggest thing is we're changing those things of management such as tillage and no-till. And moving from more tilled practices to more soil regenerative or soil health practices helps us improve our soils. So for example,
Sorry about that. It looks like the preview stopped there for a second. Give me a second and I will hopefully get that up and running again. There's technical difficulties here.
hi, my name is Jason Clark. I'm here at South Dakota University.
Hold on a second. All right, I believe we're around 11 minutes or so. Let me get back to that spot here. All right, I believe I got the video back up. Sorry about that. Just kind of technology doesn't work sometimes, but let me get that back up. I will mention again, if you have any questions, feel free to use the Q&A. It's in the bottom of your Zoom window, Q&A. Obviously, we won't be able to answer your questions, but I'm sure we can give those to Jason and he can get back to you if possible. So let me share this video again. Make it full screen. Let me push play here. All right, let's get back to it.
Anywhere from 3 in the central to 13 to 17 pounds
Hopefully you guys
overall
can
across
hear
the
everything.
state of our recommendation, improving that accuracy. Now our no-till is a little different story. We're seeing on average we're actually lowering. But that shows us this is looking at no-till regardless of the number of years we've been in no-till. But we've seen that after 5 or 6 years that tends to go away. So that's likely an update that needs to come into the recommendation in the coming years as we get some more data in on some long-term studies that we're currently working on. Dakota. And a lot of the reasons you can see here on this graphic, we're seeing an increase in corn yields. We are seeing an increase in fertilizer rates as well. Our climate in South Dakota is changing quite a bit. Our management is changing. We've gone a lot from tilled practices to no-till. Our rainfall is a little bit more sporadic. But the biggest thing is we're changing those things of management such as tillage and no-till, and moving from more tilled practices to more soil regenerative or soil health practices helps us improve our soils. So for example, some of the soil health principles of soil armor, keeping those roots intact, keeping things on the soil to help it be protected from rain and other events. We're also minimizing disturbance by not tilling or tilling less. We're letting that biota and those microbes and those fungi grow and not be disturbed. By planting a more diverse crop, instead of a 2-year rotation, do a 3 or 4-year rotation with a few more with different crops. We're getting different roots in the soil, which then have more biota and more things related to them. The more continual living roots we have through cover crops or additional crops throughout the year, we also get that. And in some parts where we're able to, we're integrating livestock. And all of these things help our soil be healthier. And when it's healthier, it shows that it helps that nitrogen cycle. And we're actually becoming more efficient, taking less pounds of nitrogen fertilizer to get a bushel of corn because our soil is likely healthier and able to provide the nutrients that corn crop needs. Sometimes I get questions about the states around us, such as North Dakota, Minnesota, Wisconsin, Iowa, Nebraska, and other people who use a different nitrogen recommendation system than we do called the maximum return to nitrogen. So that's what we're going to be talking about today, and then comparing it against our current system to see which is better or how close they are. And I think you'll be surprised that they're pretty evenly matched. So if we look at the equation behind us, we can see this is our typical nitrogen recommendation system for South Dakota with one minor change. And that minor change is here in that coefficient or that multiplier. So that multiplier went from 1.2 to 1.0, but still we're looking at that yield goal times the multiplier, subtracting our soil test N, taking care of our legume credit when it's needed, and also our no-till debit if we're within about 5 or 6 years of entering new no-till, changing from tillage to no-till. The biggest question about this is what about economics? Fertilizer prices have gone sky high in the last several years. How do we account for that? Am I still applying too much nitrogen here? So it's really going to focus on is what about economics? And I'll show you why economics are so important in this next slide here. So in this slide we have a typical response curve. We have on our y-axis over here our corn yield, our x-axis our nitrogen fertilizer rate, and this is a field in the farmer's field in Salem, South Dakota. And if we look at the response across these different nitrogen rates, we see that we increase, but we start going down until we hit a plateau. And that plateau comes about 120 pounds of N, we get about 225 bushels of corn. Now if we were to look at that zero rate of nitrogen right here, we get about 120 bushels of corn without adding any nitrogen. If we add about 40 more pounds of nitrogen to there, we're getting an increase of about 54 bushels of corn for that added 40 pounds of nitrogen. If we add another 40 pounds of nitrogen on there, we're only getting about 34 bushels per acre. If we add that final 40 pounds of nitrogen on there, so we get our optimal, we only add 14 bushels per acre. So we start off by getting 34 bushels per acre, or going from an increase of 54 to 34, up to about 14 bushels there. So you can see as we add more nitrogen, we're getting less in return. So that kind of shows us where economics are in there. So we're getting less of a return by keeping adding more, but we're still getting a return. But as long as we're paying for that increase, we're doing well. So what maximum return to nitrogen does, we're looking at yield over here, but we're also looking at nitrogen rate and nitrogen cost, as well as costs of our yield. So we've looked at multipliers before, looking at that coefficient or multiplier of 1.0 pounds of nitrogen per bushel of corn. Instead of looking at amount of urea or nitrogen fertilizer to corn bushel yield, now we're looking at price. We're going to look at the price of the urea, we're going to look at the price of the corn or whatever nitrogen fertilizer we have. So traditionally, we're looking at 40% nitrogen, $4 corn. And if we look at that, and what that equals is about 0.1 bushels of corn per pound of N, which means I need to increase by 0.1 bushels of corn for every pound of N to pay for it. But this is our long-term average. Today's average is a little different. We're around $1.03 nitrogen, $6.95 corn. So if we do the math there, we're about 0.15 bushels of corn we need to increase for every pound of N. So you can increase, you see just from that, we went from 0.10 bushels to 0.15 bushels. So we need to get more corn back per pound of N we're putting on now than we used to. So to kind of clarify this a little bit more, we're going to talk about two different definitions here. We're going to talk about agronomic and our economic optimal N rate. So our agronomic is what we think is that nitrogen rate max yield. Economic is a little different. As you can see here, you go ahead and read it. I'll explain a little bit here. It's a point where that increase in yield pays for it with the increase in nitrogen that we put. So we want that nitrogen we put on to be paid for in that yield increase. So once that stops being paid for, that's our economic optimal N rate. And I'll show you an example right here at a site in Brookings, South Dakota this past year in 2022. So we look at our corn yield on our y-axis, our nitrogen rate on our x-axis. We can see here the increases until we hit our optimal yield or our max yield, which was about 85 pounds of N. We got 224 bushels of corn. So behind that, what we're really looking at here is our economic. It's a little bit lower. So when that nitrogen stopped paying for itself, it was around 76 pounds of N, and we got a yield of 223. So only 1 bushel difference, but we save about 20 or so pounds of N, which over a field can add up to quite a bit of nitrogen there in savings. But this isn't always true in every field. We look at a different field, very close to this, except for in another part in Brookings, South Dakota. This field right here, we see the response curve is a little different. It increases a little bit slower than before. So our agronomic is over here at 206 pounds of N, while our economic is over here at 148 pounds of N. So that's around a change, about 50 pounds of N per acre. So that's a really big difference. So if we want to look at this example here, we're going to stick with this Brookings field, here, and we're going to change it a little bit. So instead of looking at corn yield on our y-axis over here, we're actually going to be looking at dollars per acre. And here we're still looking at nitrogen rate. We're going to have 3 lines we're going to show up. This first one is nitrogen cost. So as you can imagine, as you apply more nitrogen, just like this blue line goes up, our cost of nitrogen is going to go up. Now if we look at our yield response for how much profit we get from our yield, it goes like this. We see that sharp increase, but eventually it's going to flatten out like it did. And then we're going to get our net return, which is that green line, which is our profit, subtracted from that blue line, which is our cost. And that shape looks about like this. So as we increase in nitrogen rate, we increase in profit until we hit an optimal, which is right here. And we go plus or minus $1 of that optimal, we see this range right here, about 70 to 80 pounds of nitrogen in this field. But if we keep increasing to 90, 120, 150 pounds of N, we're seeing how much we're decreasing. We can actually decrease in profit by about $40 per acre by over-applying nitrogen. Now, this maximum return to nitrogen doesn't work by one field by itself. It can over time, so you can get this. It takes about 5 or 10 years in your fields to do it, but it can be good so you can see what that range of nitrogen requirements is for your field. But if we do this across all of South Dakota, we get an economic optimal nitrogen rate in today's corn prices, nitrogen prices of 103 pounds per acre. If we divide that by eastern and central South Dakota, we get 105 pounds of nitrogen in the east and 81 in the central part of the state. So how accurate is that? So we take 2018 to 2021 data, and we subtract it from the actual amount needed. We're going to look at this graph right here. So closer to 0 is better, Positive numbers are overestimations of nitrogen, negative numbers are underestimations. So if we just use that South Dakota recommendation, we see generally an overestimation of around 40 to 60 pounds per acre. If we use east and central South Dakota, we want that line to get closer to 0. We can see over here in these central sites, normally that blue line is closer than that red line, which shows us the central part of the state definitely benefits from dividing the state, whereas the eastern part doesn't show us as much benefit, but it is showing a similar accuracy whether we divide it or not. We definitely need to do that in the central part of the state. So overall, when we look at this, using the whole South Dakota maximum return nitrogen, we're plus or minus 40 pounds of N. East, we're plus or minus 37. Central, plus or minus 50. So still working on that accuracy there. Now, if we want to add in 2022 data, how does that affect this recommendation? So if we go from 103 pounds to 97 pounds across the state, 81 down to 60 in the central part of the state, which actually shows us that our rate probably needs to be a little bit lower as we see some of these dry years continuing, and the eastern went down just a little bit from 105 to 102, so not a big change in eastern South Dakota. If we want to look at the accuracy here, and the accuracy again, the red line is across all of South Dakota, the blue line is using the east versus central. So you can see again in the central part of the state, we normally are seeing areas where we're using that improving by dividing up the state, whereas the eastern part over here, not as much. We want to look at the accuracy overall, plus or minus 42, plus or minus 37 in the east, and plus or minus 38 in the central, which is better than plus or minus 50 when we didn't have that 2022 data in there. So you can see maximum return to nitrogen gets better as we get more and more data in there as what we're working on right now. So if we're trying to predict 2022 from 18 to 21 data, we see that we're plus or minus 40 pounds of N per acre. Improve some by dividing out by east and central. We're predicting all the sites across South Dakota with 2018 to 2022 data. We're plus or minus 42, so pretty similar there. Plus or minus 37 or plus or minus 38 for the central part of the state. So the MRTN is getting better as we're getting more data into it. Now if we want to compare that to our current yield goal-based system, which is using a 1.0 multiplier now, not this 1.2 noted here. So we look at that information, we're about plus 13 on average, or plus or minus 45 from 0. Now if we look at predicting 2022, we're plus or minus 40, which is a little better than what we're seeing here, but plus or minus 37 or plus or minus 50 there. 2018 to 2022, plus or minus 42, plus or minus 37, 38. So you can see using this MRTN approach, we are getting better at getting a little bit closer than maybe this 1.0 coefficient. However, we're still tending to overestimate a lot of sites using this MRTN fashion. We're not overestimating as many sites with this 1.0 yield goal approach, which is why we're sticking with it for now. However, we'll see in the future if getting more sites and more information, the more soils information in this equation can help us further improve our recommendation. Today we're going to be talking about the future of corn nitrogen work. A few months ago, someone asked me, so what do you see as the future work for nitrogen recommendations? So I took some time to think about it and went over to my crystal ball, as you can see here, and kind of thought about, well, what does it look like for me? And that's what we're going to be discussing today. So let's go ahead and get started. Let's look at what we're doing right now. So typically when we do and we work on corn nitrogen fertilizer requirement studies, we do something like this. We go to individual fields, as much of the state as we can, and we plot our corn yield versus nitrogen fertilizer requirements, such as this field in Brookings in 2022, and we see about how that field responds to corn nitrogen fertilizer and where it optimizes. So in this field, around 85 pounds of nitrogen and 224 bushel yield. If we look a little bit more about economics, it's about a 76 pounds of N, and with just a decrease of yield about a bushel per acre. So next, if we look at, we do this not just in one site, but here you can see we've looked at 45 locations from 2018 to 2022. And a lot of these may be close to where you are, maybe a little bit farther away, but what I see as the future is taking this from a full state, looking at different places, as many as we can, to you being able to get this closer to your own backyard with or without my help. So if we look at this, go to our backyard, go to our field, and we take that and, say we put in zones of different areas. And then what would be next to look at this in our own field would be taking these nitrogen rate studies. Instead of doing them in one place, we can take these and do a range of rates going from 40 to 80 to 200. And we can put them in multiple places in this field, 200 to 400 feet long or all the way across the field or across the zone. And we can look at these, how big they are, how small they are. They wouldn't take up your whole field because we don't want to do that much, but they can take up small portions. So we do that, and what happens with the results is instead of getting one yield curve per field in a year, what you're doing is you're actually getting multiple per field if you're doing multiple of these, and you're getting these different rate response curves that we talk about so frequently, but you're getting them for multiple places in the field or for each individual field in your production area. And with that, you have a lot of power to be able to move your own nitrogen rates without relying on other people. You can look at your own efficiencies and things like that, and we can work with you with developing and looking through the data. If 4 or 6 nitrogen rates isn't really up your alley, you think that's too much, well, let's start out with just 3. So instead of going 0 to 200, let's look at just using our normal rate, subtracting 45, and adding 45 to that normal rate. And we can do that in multiple places in a field, and we can see based on where I am in my field, does that change the rate for my normal rate? Do I need to up it? Do I need to decrease it? And then the next year you can, based on that, you can up it and decrease it there and kind of hone in on what that rate would be for your individual field. So hope you enjoyed those ideas of what some future fertility might work, going from lots of places in the state to your own backyard into your own fields and your own operation, and developing the data yourself, working with us or individuals or other people. Today I'm going to be talking to you about soil nitrogen products or nitrogen rate products that hopefully decrease our nitrogen requirement, or they enhance crop yield, or do many different things like that. So let's go ahead and get started. So if we look over here on our slides, we can see a bunch of different microbes, different fungi, different microscopic ones, and some of these are great and they do a lot of good things. And there's sometimes very good nitrogen products out there that do help protect our nitrogen from either volatilizing or leaching down further in the soil. However, of recent years, a lot of these companies are taking these products, putting them and marketing them to us. And sometimes they'll come to us with data that looks a little bit like this. They'll say, well, if we put 160 pounds of nitrogen on, we get a yield of 190 bushels. If we put 120 on plus our product, we get 188 bushels per acre. So in essence, you're saving 40 pounds of nitrogen if you use our product. But my question is this. Looking at this data, what questions should you now have for that person selling you this product? But before we get into specific questions, I want to go over one concept, and that's corn's response to nitrogen rate. So here on this graph here, we have our corn yield on our y-axis, we have our fertilizer nitrogen rate again on our x-axis, and this is what we typically see when we do yield against nitrogen rates increasing. They slowly increase at first, we get an increase in yield with more nitrogen rate, and then we slowly optimize where we're no longer getting an increase in yield. For instance, here we're optimized about 120 pounds of N per acre. But if we remember, that study compared 160 pounds of nitrogen and 120 pounds of nitrogen per acre. So both of these without a nitrogen rate product, we can see their yields are equivalent. They're pretty much the same yield, 40 pounds difference in nitrogen rate requirements. So the important thing to think about with this curve and testing nitrogen products, instead of testing them at 2 or higher rates, such as we see right here, at 120, 160, it's really best to choose one of these rates down here lower where this curve is going up. So we see right here between 50 and 80, we're increasing in yield. So if we're really going to save nitrogen, this is where we're going to know for sure in this range we're going to. And we can also compare it to a higher rate, such as a 120 to 160, depending on your field and your yield potential. But we really want to make sure when we're testing these products that we go for a lower rate to see if it really is saving us nitrogen fertilizer requirements. So what this might look like in your field, if you do put zones in your field or do it as a single field, what we want to do is do this in a certain area of the field, not just half a field and half a field, because of the soil yield potential differences can vary quite a bit. So we take this in a zone or an area in our field that's fairly uniform, and we can put out a trial that looks a little bit like this. It can have a product, a no product, a product, no product, product, no product. And this basically gives us 4 replications of no product, 4 replications of product, so we can see the little variability in replication if this product works. And if we have the means, we can even do it in multiple areas of the field to see if soil type in this field changes our results at all. As always, thank you for your time, and I hope this has been a benefit to you. And as you test out these nitrogen products, hopefully you'll share your results and we'll be able to learn together of if they work and when and where they work. Thank you.
All right, everyone. Thank you for sitting through the little hiccup there we had. Again, Jason, he wasn't able to be here today, a medical emergency, but he did, put that recording together for us. Um, there's a poll here that Jason wanted to get some information from you guys. So if you see that, please fill that out. Send that information to Jason. I did see Kira did put Jason's contact information in the chat. So if you do have any questions that pertain to this talk, please feel free to send those to Jason. To fill in time and hopefully get a credit for you, or that CCA credit, we are going to try to play one more video, a 10-minute video from Jason. It doesn't pertain specifically to corn, but it is a soil fertility guidelines based out of, for South Dakota. So once that poll finishes up, we will move on to that video and hopefully get you guys some more information. Again, apologize for the complications more or less, but like I said, Jason wasn't able to get here, but hopefully we can get you guys some pertinent information regardless. So with that, I'm going to start this next video. Again, it's only about 10 minutes long. Hopefully you guys can learn some more. So let me get that video up and we'll move on to that.
Hi, my name is Jason Clark and I'm here at South Dakota State University, and today we're going to go over how to use the soil fertility equations workbook and determine nitrogen, phosphorus, potassium, and sulfur rate guidelines for corn, soybean, and wheat in South Dakota crops. So the first thing we're going to do is we're going to open our workbook, and once we open it, we're going to see this on here. As you can see on this page, we have 7 different tabs on the bottom right here. We have, starting over here, our first 4 tabs are our nitrogen, phosphorus, and potassium recommendations, starting with corn grain, corn silage, soybean, wheat, and rye. And then our next one is our sulfur fertilizer recommendations, which is for all crops. Our next tab or worksheet is one that has legume credits in it to remind us what they are, as well as a calculator to change parts per million in your soil test to pounds per acre that we need to use in our fertility recommendations. So first of all, we're going to go over the corn grain nitrogen, phosphorus, and potassium worksheet. Then we'll quickly go through the other ones because they're very similar. So first of all, we'll see here as we pull it up, this area here, we have the instructions. Generally, the cells that are yellow require us to input information. Those cells that are gray or white are those that are informational, or there's a calculation, so we won't do anything there. So step 1 is we need to choose the multiplier for the corn nitrogen per bushel of grain multiplier. So recent research has shown that that value used to be 1.2, however now we've moved to 1.0. However, in some eastern parts of the state, 0.9 is also very accurate. So if we want to look at changing that, we can click on this 1.0 cell right here, and we could use this drop-down list to choose 1.0, 0.9, or 0.8. The default will be 1.0 as that's shown to be the most accurate. But also in some parts of eastern South Dakota, 0.9 is also accurate. So you can kind of see, if you play with that number a little bit, what might be changing as far as your rate recommendation goes. So we're going to leave this at 1.0. Then we're going to jump down to step 2 right here. This is going to be our soil test phosphorus. We have 2 phosphorus tests that you can get from lab reports that are common in South Dakota that we have recommendations for. The first one is Olsen phosphorus, and the second one is Bray phosphorus. Olsen phosphorus works well on high pH soils and low pH soils. Bray works best on lower pH soils below 7.4. So if we have our Olsen phosphorus, we can leave this here. However, if we have our Bray, we can click on that cell, use that drop down, and switch to Bray. This is important because the information that we use in the chart below us will need to be the same as what's here, or else the recommendation won't show. So we're going to switch it back to Olsen. We're going to use that. We're going to go to step 3 right here, and this is going to show us each of the different columns in this data input right here. So our first thing is our field ID, and I just have an example here putting Brookings 1. Our next thing we're going to do right here is our yield goal. and we have information for each of these right here that you can read on your own. But our yield goal here, and this is our yield potential for the field, we're going to say it's 160 of this field. Our soil test nitrogen, that 0 to 24 inch value, goes in our next column. We're going to use a value of 40 right here. And then our legume credit, we're going to say our previous crop was soybean. We also have this calculator down here, this legume credit chart. If you want to look at it, if your previous crop was soybean or alfalfa or things like that, you can look at here and see what that number might be. This no-till nitrogen adjustment, if our no-till is within about 5 years, we can add about 30 pounds of this credit by clicking on there. However, if we're no-till long time, we can probably leave it at 0. If we're conventional till, we also would leave it at 0. Now this next one is Olsen phosphorus. If we did an Olsen phosphorus test, then we would put a value in here. However, if we did a Bray phosphorus test, we put it in the next column right here. So here we're using an Olsen phosphorus test, and then we're going to leave the Bray phosphorus test blank. And then our next one is potassium. So here we say our potassium is 233. And then after we put that information in over here, we can see that our nitrogen recommendations come up here as 80 pounds of nitrogen per acre. Our phosphorus is 6, and our potassium at 0. So let's say we actually took the Bray phosphorus test instead. We can switch this number, say it was about 12 parts per million Bray phosphorus. We'd go back up here to step 2 and we switch this to Bray phosphorus. Then go back down here, we can see that since we switched that Bray phosphorus to here, we now get a recommendation, and our recommendation now is 45 based on this Bray test. And say our potassium recommendation came back to 233, it was only about 140. And then our potassium recommendation comes up about 60 pounds of potassium per acre. So you can add in different fields all the way going down this column here until we run out. Below here, this is a link to the fertilizer recommendation guide to where these numbers come from. These are the equations used in the workbook that we're using right now. These are the soil test calibration levels, the probability we'll see a response based on the soil test here. And then this is the chance we're going to see a response based on what category we're in. Say Bray phosphorus 0 to 5 is 80% chance response, 6 to 10 is 60 to 80% chance response, 11 to 15 is 40 to 60% chance we'll see a response, 16 to 20 is a 20 to 40% chance we'll see a response, and above 21 there's less than 20% chance we'll see a response. So normally we wouldn't advise to apply fertilizer at this point when we're at that level of phosphorus fertilizer. So this here is what we use to get those recommendations for nitrogen, phosphorus, and potassium for corn. If we're using corn silage, it's very similar. The only difference is you notice we won't be choosing a multiplier up here. That's because there's not options for it. It's just a single option, so that's just in the recommendation itself. But you can also go through here, choose the Olsen phosphorus test, and then use step 2 to choose these various components right here and input them into the data sheet right here, and we can get our recommendations for corn grain silage. The wheat and rye is exactly like this one. We choose our Olsen test. We put in the rest of our parameters down in here, and we have examples here of what some different ones might be and their recommendations. Soybean is a little different, as soybean doesn't require nitrogen, so we just have a step for phosphorus, and then yield goal, phosphorus, and then potassium. And our nitrogen recommendation is always going to be 0 right here. But we'll get back phosphorus and potassium recommendations based on our soil test levels. The all crops for sulfur recommendation is this right here, and that has a couple different steps. Step 1 is we need our soil texture, then our tillage practice, and then our soil test sulfur down to 24 inches. And that 24 inches is important because 0 to 6 is not a very usable number, but 0 to 24 has been shown to work much better. So here we're going to put our field ID. We're going to click on soil texture, and we have a drop down. We can choose between a coarse soil, which is higher sands, medium fine textured soil, which is more of your loamy, clay loam textures. And then we're going to choose our tillage practice, which is going to be a conventional till or choose strip till or no till. And then we're going to input our soil test sulfur value. Say here it was 15 pounds sulfur per acre, and that comes back with a recommendation of 25. Our next worksheet here is our legume credit and our parts per million to pounds per acre calculator. So we'll start up here, and again, these are the instructions. You can see here we input in yellow cells, get information back in gray cells. So here we're going to put the beginning depth. So say we're doing our topsoil starting at 0, we're going down to 6. We get our soil test sulfur value of 9. We show that changes to 18 pounds per acre. Then we do another test from 6 inches to 24 inches in depth. We get a value of 4. That calculates out to 24 pounds per acre. Let's say we go even deeper at this site. We go 24 to 36. Another soil test value of 4, 16 pounds per acre. And then here, if we have all the same depth, we can use that to total up as at 58 pounds per acre. And then we can use that number to go back here and put it into our sulfur value right here. Say that was 58, say that was actual. We'd see our sulfur recommendation was 0 in this case. However, if we're just doing nitrogen, then we're at 0 to 6 and 6 to 24, these same values, we see 42. We can go back to our corn grain. Instead of using that 40, we can say it was 42. You can see it adjusts over here for what that should be. Our next one is our legume nitrogen credits. So this is here, we look at our previous crop. With soybean, edible beans, lentils, or others, we have nitrogen credit of 40. If it's alfalfa or a green legume, you can see based on the plants per square foot, we get the nitrogen credits here that would then go in the columns here for nitrogen credits. We can type them in 40. If it's maybe after a good alfalfa crop, this would be such as 150. You can see your recommendation when you do that actually goes down to 0, which is pretty common. We've seen that in Minnesota and out in the West as well, where if you have a good alfalfa crop going into corn, you don't very often need nitrogen to supplement. Our last worksheet is our equations. This is the equations for all of the crops that you can see here, our nitrogen recommendations, our phosphorus recommendations, using the Olsen test, and then our potassium recommendations. So these are what are used. So I really hope that this helps you kind of understand how we can use these different calculators to help input that information and then get back these nitrogen, phosphorus, and potassium rates, as well as sulfur, using our other spreadsheet. And I hope this information is valuable to you and your operation and can hopefully make your life easier. Thank you for your time today.
All right, thank you, everyone. So that was just a short video to kind of fill in space here. Kira did put that Excel sheet that he just showed you in the chat there. So if you want to take a look at that, you can. It is on our extension website at all times. It's the basically fertilizer rate guideline calculator for not just corn, but soybean and wheat as well. So if you can click through that if you want to. Again, if you have any questions that pertain to either of these talks or topics, Jason's contact information is there, jason.clark@sdstate.edu, as well as his phone number. So again, for I apologize for the technical difficulties. I feel like we got, at least some information out there to you guys. Thank you for joining us. Next week, we will be covering precision agriculture. The week after that will be soybean. That I will be hosting the soybean one. So please join us, in the next coming weeks. We got a lot of good information. I think that, will be pertinent to you. Kira also put in the chat, we have our pest and crop newsletter that is delivered weekly throughout the growing season. So this coming summer, we write short articles in this newsletter and we give them to send them out to newsletter subscribers. And basically what that is it shows pertinent information. So if, let's say, we see an insect that just appeared, it'll be in that newsletter and then to look for it. Longer. I believe that is pretty much it for today. Again, thank you for joining us. I will give you another 10 seconds or so if you want to scan that QR code. I believe, let me look at the QA here. It appears as though the link for the newsletter isn't quite working. Kira, I don't know if you want to post a new link or not for that. If the link is broken, you go to extension.sdstate.edu and then search newsletter in the top right, the search bar there, and it will bring you to the newsletter. And there is more than just one newsletter, so it looks like a new tab there. We have a pest and crop newsletter, but there are other newsletters, not just pest and crop. We have garden, rangeland, I believe. So feel free to please check that out. Okay. All right. I'm going to stop the QR code here. Okay. Look in the chat here. Look at any questions. Looks like we're all good. All right. Well, thank you everyone again for joining us. I do apologize for the technical difficulties, but hopefully you learned something, and hopefully we'll see all of you next week and in the weeks after that. All right. Thank you.